Yes, Rishabh, part 2 is correct. Vigyan, check part 1. Adrija, part 1 is correct. Soham, part 2 is correct. Abhipsha, part 2 is correct. Rasheshwari, part 1 is correct. Shamali, check part 1. Ronak, part 2 is... Ronak, check part 2. Okay, everyone pay attention. Part 1. Limit extends to 0. Box of sin x by x plus box of sin 2 square
Sir,
x by x. Pay attention, everyone. Yes, tell me, Swam.
sir, part one answer is a finite value or in terms of n.
Which one? Part
Part
1?
uh,
No, right, in terms of n.
अबे,
Okay. What happened, Swam? Okay.
So can you show question number 3 and 4 again?
Yes. So everyone, this will become, pay attention. Limit extends to 0. Okay. Now see, sin x by x is just less than 1. Yes or no? As x tends to 0. This is something just less than 1. Yes or no? Tell me. Next. Plus, this is sine 2 square x by x. So everyone, this is just less than 2 square. Yes or no? Tell me, everyone. Are you people getting? If you are unable to understand, pay attention. Okay. Limit x tends to 0, sine n square x by x. If I'm writing sine n square x by x, basically this will be nothing but sine n square x by n square multiplied by n square. N square x multiplied by n square x. Wait a minute. Multiplied by n square. Okay. So this will be nothing but n square only. Are you people getting? Are you people able to realize sine x is less than x? Next. The third term. The third term will be just less than 3 square. Are you people able to visualize? Plus dot 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 dot. This will be just less than n square. Okay. We have to take the box function of this. So everyone, this will be limit x tends to 0. What is the sum of the squares of first and natural numbers? It will be n into n plus 1 into 2n plus 1 by
2n
6.
plus 1 by 6.
Exactly. So the whole summation is just less than n into n plus 1 into 2n plus 1 by 6. So when you open the brackets, this will be n into n plus 1. When you apply the limit, it will be n into n plus 1 into 2n plus 1 by 6 minus 1. Right, tell me. Why minus 1? Because it will be on the left branch. It is just less than n into n plus 1 by n into n plus 1 into 2n plus 1 by 6. Tell me, anyone having any doubt, you can ask me now. Okay. Tell me, Anvesha, is it clear? Abhisha, Abhigyan, are people getting?
Yes, sir.
Joyatra, Srijita, Shubhankit, are you people
Yes.
getting? Tell me. Next. If you people are getting, quickly solve the second one. Yes. Rasheshwari, second and the third one is correct. Adrija, second one is correct. Samrakni, third one is correct. Let me see. Yes, Shamli, second one is correct. Ahir, part 1 and 2 are correct. Ronak, part 2 is correct. Shubhangi, part 2 is correct. Abhisha, check part 4. Yes, Rasheshwari, part 4 is correct. Abhisha, part 3 is correct. Let us start with part 2, everyone. limit x tends to 1, sine of fractional part of x upon fractional part of x. So over here, we need to check the left hand limit and right hand limit. Because, because fractional part of x changes its definition around x equal to 1. Pay attention, everyone. LHL and RHL. This is part 2. Yes, Samrakni, part 2 is correct. Everyone, what is LHL? LHL will be limit x tends to 1 minus. So can anyone tell me the definition of fraction part of x when x is tending to 1 minus? Raise your hand. Tell me the definition. Tell me what will we get as the expression in place of fraction part of x? Tell me. Raise your hand. Yes, Samragni, tell me.
X minus box X.
X minus box x. That is the whole definition. I'm just asking you what will be the branch when x is tending to 1 minus? What will be the equation? Yes, Soham, tell me.
So sin x by x.
Sin x by x. Absolutely correct. It will be in y equal to x branch. Right, Samrakni, are you getting? This is 0. This is the branch originating from 0. This is the branch originating from x equal to 1. The equation of this branch is x minus 1. The equation of this branch is x. So it will be sin x by x. What is the limit? Over here, the limit is sin 1. Don't write it as 1, everyone. Don't make this mistake. It should be 0 by 0 form. Then only it's an identity. RHL, right hand limit, everyone. Right hand limit will be limit x tends to 1 plus. So 1 plus, in which branch it will be, everyone? What is the equation of the branch for 1 plus? Everyone tell me, what is the equation of the branch? Anyone raise your hand. For 1 plus, what will be the branch? Yes, Shashwato, tell me.
Say x minus 1.
X minus 1. So it will be sine of x minus 1 by x minus 1. So now see, it is the standard form, everyone. It is sine 0 by 0. So this limit will be equal to 1. So since LHL is not equal to RHL, since left hand limit is not equal to our right hand limit, limit does not exist. Next, Adrija, part 3 is correct. Part 3 I'm solving, everyone. Part 3 is limit x tends to pi by 6. So are you people able to understand? It is 0 by 0 form. When you substitute pi by 6, you are going to get 0 by 0 form. Limit x tends to pi by 6. This is number part 3. Pay attention, everyone. So since it is 0 by 0 form, what you do is you have to convert and remove the indeterminate form. So limit x tends to pi by 6. First of all, take 2 common. See, everyone, it is a cos x minus b sin x. Do you remember, everyone? Whenever you get a cos x minus b sin x, we have to multiply and divide by root over a square plus b square. So you take 2 common. See, what are you getting? 2 common. Within brackets, you are going to get 1 minus root 3 by 2 into cos x minus half sin x. Okay, divided by 6x minus pi whole square. So you take 6 square common, 36 common. You are going to get x minus pi by 6. So see, numerator should also be in this form only, x minus pi by 6. Everyone, let us see what are we getting. 2 times this will go 18. So this is 1 upon 18 multiplied by 1 minus root 3 by 2. Let us convert minus common. Let us convert it as cos pi by 6 into cos x minus sin pi by 6 plus sin pi by 6 into sin x. Okay, everyone. So see, it is 1 cos x formula, cos a minus b formula divided by x minus pi by 6 whole square. So see everyone, this will become 1 by 18 multiplied by 1 minus cos of x minus pi by 6 divided by x minus pi by 6 whole square. Just check whether the argument is tending to 0 or not. So when x is pi by 6, everyone, when x is pi by 6, x minus pi by 6 will tend to 0. So everyone, see, we have got a standard form 1 minus cos theta upon theta square. What is 1 minus cos theta upon theta square? Tell me, everyone.
Half.
Half. So this will become 1 by 18 into half. This will give us 1 by 36. Tell me, anyone having any doubt, you can ask me. Next. Everyone solve the last one. 1 minus cos x into cos root over cos 2x. Yes. Soham, your answer is correct. Adrija, check part 4. Rishabh, part 3 is correct. Anvesha, check part 4. Okay, everyone, I'm solving part 4. Okay, Shamli, part 4 is correct. We have got 1 minus cos x into cos root 2 into root over cos 2x divided by x square. Let us start, everyone. Yes, Adrija, part 4 is correct. Part 4 is correct. Yes. Ronak, part 4 is correct. Shubhangi, part 4 is correct. Anvesha, part 4 is correct. Shashwato, check part 4. Rishabh, part 4 is correct. Everyone pay attention. Okay. See, you must be applying the limit like this. When x is tending to 0, root over cos 2x will tend to 1. So you'll get limit x tends to 0. 1 minus cos x upon x square. You must be applying it like this, right, everyone? This, and then again you will say that this is equal to half. But this is wrong, everyone. But this is wrong. Why it is wrong? Because whenever you are applying the limit, you have to apply limit all at once. Limit should be applied to all the function at once. Over here, what mistake you are doing? You are applying the limit first to this expression, and then you are applying the limit to the remaining expression. Okay. You have to apply the limit all at once. Okay. So I'm showing you the correct method. Yes, Samragni, right answer. Correct method. See everyone. So see everyone, in the numerator we have got root. Okay, you have got a minus root b something. So apply rationalization. We'll get 1 minus cos x into root over cos 2x. Let us rationalize. Multiplied by 1 plus cos x into root over cos 2x. Okay. Divided by x square into 1 plus cos x into root over cos 2x. Okay. So see everyone, in the numerator we are going to get 1 minus cos square x into cos 2x divided by x square into 1 plus cos x into root over cos 2x. Over here it is free of any indeterminate form, this bracket. Okay. Next, in the numerator 1 minus cos square x, can I write it as 1 minus sine square x? Let us convert everything into sine square. 1 minus sine square x, and cos 2x can be written as 1 minus 2 sine square x divided by x square into 1 plus cos x into root over cos 2x. Okay. Next, this will give us 1 minus, within brackets, 1 minus 2 sine square x minus sine square x, that is 3 sine square x. plus 2 sine to the power 4x. This whole thing is divided by x square into 1 plus cos x into root over cos 2x. Okay. Next, when you open the brackets, 1 will get cancelled. You'll get 3 sine square x minus 3 sine square x minus 2 sine to the power 4x divided by x square into 1 plus cos x into root over cos 2x. So see everyone, in the numerator, if you take sine square x common, you'll get a standard form. In the numerator, if you take sine square common, you'll get a standard form, everyone. That is sine square x by x square. And over here, we are getting 3 minus 2 sine square x upon 1 plus cos x. So this is where the indeterminate form lies when x tends to 0. Tell me, are you people getting? Yes or no? Shashwata, are you getting?
Yes, sir.
This will get cancelled and you'll get 1. When you substitute x equal to 0, we are getting 3 by 1 plus 1. That is 3 by 2. Tell me, anyone having any doubt, you can ask me now.
Sir,
Yes, tell me.
had we only converted that cos 2x into sine, wouldn't that be little easier? Uh,
Which one? This one, root
no,
cos
no,
2x.
no, yes, yes. After that, after the step of rationalization, that's
Over here.
yeah.
So you want to
Then
convert it into as 2 cos square x minus 1.
no,
What?
cos 2x as in 1 minus 2 sine square x, but not converting the cos square x also. Just the
Achha.
cos 2x I'm converting. Then
I
directly it
don't know.
was
I haven't applied it yet. I have to apply and check. Okay. Anyways, I hope this is clear to everyone. Next. Note. So just now we have seen that limit should be applied. Limit should be applied. Limit should be applied all together in the function. Should be applied all together in the function. Okay. Not separately. Okay, I'll show you why. Part 2. Why? Because we should understand that after applying limit, after applying limit, there shouldn't be any term. There shouldn't be any term with variable x, or there shouldn't be any indeterminate form left, Indeterminate form left. Like for example, over here you see after applying limit only to root over cos 2x, an indeterminate form was still left. Okay. So whenever you are applying the limit, there shouldn't be any term with variable x. Okay. I'll show you another example why this is wrong. See, limit x tends to 0 when you are writing sine square x by x square. See, we can also write it like this. Limit x tends to 0 sine x into sine x by x square. Right, everyone? We can also write it as limit x tends to 0 sine x by x square. But over here, what is the problem? That when you substitute x equal to 0, you might write it like this: 0 into sine x by x square, which is equal to 0. Right? But this is wrong. Right, everyone? But this is wrong because we have already seen that limit x tends to 0, sine square x by x square is equal to 1. So see, after applying limit, after substituting the value, there shouldn't be any term with variable x left. Okay, next. Question number 2. Question number 2. x1 equal to 1, xn plus 1 is equal to root over 1 plus xn square minus 1 upon xn for n greater than or equal to 1. Okay, and n belongs to natural numbers. Find the value of limit n tends to infinity 2 to the power n into xn. Solve. Next, question number 3. Limit x tends to 0, sine a plus 2x minus 2 sine a plus x minus 2 sine a plus x plus sine a upon x square. Solve. Question number 3 part 1. 3 part 2. Limit x tends to 1, 1 minus x into tan pi x by 2. Okay, part 3. Limit x tends to 0, 1 minus cos of 1 minus cos of x upon sine to the power 4x. Question number 4. If limit x tends to 0, x square into cos of pi sec square x into cosec of pi sec square x is equal to 1 by n pi for some n belongs to natural numbers. Find n. Solve quickly. Yes, Adrija, number 2 is correct. Ahir, number 2 is correct. 3 part 1 is correct. Adrija, 3 part 1 is correct. Joyatra, check 3 part 1. Okay, Soham, at least write down the question number. Shinika, 2 is correct. Rasheshwari, 2 is correct. Everyone pay attention. Yes, Shamili, 3 part 1 is correct. Joyatra, 2 is correct. 3 part 1 is correct. Soham, check number 2. Shubhangi, 2 is correct. Okay, Abhipsha, check 3 part 2. Okay, Soham, check number 2. Okay, let us start with number 2, everyone. Pay attention. Okay, it's an interesting problem. X1 is equal to 1. Xn plus 1 is equal to root over 1 plus xn square. Minus 1 upon xn. So tell me, everyone, over here, what should we place? Over here, what should we place in place of x? What should we substitute in place of xn? By looking at the expression, what do you think we should place? Raise your hand. Tell me. Just look at the expression. It is root over 1 plus xn square. So what should we substitute? Tell me. Raise your hand. Yes. Ahir, tell me.
Sir, tan theta.
Tan theta. So everyone, let xn is equal to tan theta. Okay. Let xn is equal to tan theta. Okay. So what will we get? Xn plus 1 will be equal to root over 1 plus tan square theta minus 1 upon xn tan theta. So what are we getting? Sec square theta minus 1 by tan theta. Actually, sec theta minus 1 by tan theta. Now, what do we need? I need to find out limit n tends to infinity 2 to the power n into xn. Okay, everyone? Over here, what is x1? x1 is equal to tan theta. Okay. So what is x2? Let's see. x2 will be equal to sec theta minus 1 by tan theta. Let us simplify. Everyone. This will give us how much? 1 minus cos theta upon sin theta. When we multiply by cos theta in the numerator and denominator. 1 minus cos theta upon sin theta, this will become tan theta by 2. So everyone, I have got x2 is equal to tan theta by 2. If x1 is equal to tan theta, x2 is equal to tan theta by 2. So everyone, what is x3?
Sir, how is x1 tan theta?
I have taken x1 tan theta.
You
Wait
took
a
x2.
minute. Wait. I have taken xn is equal to tan theta. Right. So if x1 is equal to tan theta, what will be x2? x2 is equal to tan theta by 2. By using this relationship, tell me. I took xn equal to tan theta. I got xn plus 1. Pay attention. I took xn is equal to tan theta. I got xn plus 1 as tan theta by 2. Right, tell me, Soham.
Yes, sir.
Tell me, others are getting? Yes or no? Tell me, Abhipsha, Abhigyan, Anvesha, Joyatra, Rashesh, Madhurjo,
Yes.
Ritam, Shamili, Shirika, are you people getting? Shijita, are you getting? Shavankit,
Yes.
can you understand? That if xn is equal to tan theta, xn plus 1 is equal to tan theta by 2. So now see, If x1 is equal to tan theta, x2 will be equal to tan theta by 2. x3 will be equal to tan theta by 4. x4 will be equal to tan theta by 8. Dot, 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 dot. What will be the value of xn? Tell me. After n steps, what is the value of xn? Tan theta by 2 to the power n minus 1. Yes or no? Tell me, everyone. Are you people getting? So what is limit n tends to infinity? 2 to the power n into tan theta by 2 to the power n minus 1. So see, as n tends to infinity, this particular argument will tend to 0. So let us convert it into standard form. Let us divide it by 1 by 2 to the power n minus 1. But when you are dividing by 1 by 2 to the power n minus 1, you have to multiply by 1 by 2 to the power n minus 1. Right, everyone? So see, this whole limit will become 1. And you are going to get 2 only. Right? 2 to the power n into 1 by 2 to the power n minus 1. That is 2. Okay. So what have we got? I have got limit is equal to. Wait a minute. Theta. I have to divide it by theta by 2 to the power n minus 1. Okay. So I'll get 2 theta, everyone. 2 theta. Okay. So let us see. Over here, x1 was 1. So everyone, if x1 equal to tan theta, this is equal to 1. So what is the value of theta? Tell me, everyone. If tan theta is equal to 1, what is the value of theta? Pi by 4. So what is the limit? So limit n tends to infinity. 2 to the power xn will be equal to 2 into pi by 4. And 2 into pi by 4 will give us pi by 2. Tell me, is it clear to everyone? Yes or no? Tell me, Shashwata, is it clear? Samragni,
Yes, sir.
Ritam, are you getting? Madhujo, is it clear? Okay. So note it down, everyone. If it was, note it down. If it is, if it was root over 1 minus xn square, then what we should have taken? Tell me. Take xn is equal to, tell me. If it was root over 1 minus xn square. Yes, Adija, tell me what we should have taken.
Sir, sine theta or cos theta?
Sine theta or cos theta, correct. And if it was root over xn square minus 1, then what we should have taken? Xn is equal to, yes, Shamili, tell me. Hello, Shamili.
So cot square theta.
Cot? No. Rasheshwari, tell me.
So sec theta or cosec theta?
Sec theta or cosec theta, right, Shamili? Sec theta or cosec theta. Okay. Everyone quickly solve the second one. I mean, 3-part one. Let's see who has done it. 3-part one. Yes, Rasheshwari, 3-part one is correct. Adrija, part 2 is correct. Part 3 is correct. Everyone, let us start.
Sir, could you check mine? 3-part one.
3-part one. Okay, Shinika, 3-part one is correct. Rishabh, 3-part one is correct. Okay, let us start, everyone. 3-part one. So 3-part one, we have got sine of, pay attention, everyone. Sine of a plus 2x minus 2 sine A plus X plus sine A. If you are able, if you are able to understand that the angles are in AP, A plus X, A plus 2X. Okay. So what you can do is you can factorize. You can pair. Okay. You can pair some of the terms. See everyone. Okay. This is part 2. So limit x tends to 0. Okay. Can I write it as sine of A plus 2X minus sine of A plus X minus sine of A plus X plus sine A divided by x square. So see everyone, in the numerator, we have got sine C minus sine D formula. What is sine C minus sine D? This will become 2 cos A plus A. That is 2A plus 3x by 2. So that will give us A plus 3x by 2 into sine A minus. This will become 2 cos A plus x by 2 into sine A. The whole thing is divided by x square. Next, see sine A is common. So let us take out sine A. After taking sine A common, we have got limit x tends to 0. 2 sine A common, we've got limit x tends to 0. Cos of A plus 3x by 2 minus cos of A plus x by 2. Okay. So again, we can use cos C minus cos D formula. So this will become 2 sine A. Limit x tends to 0. Cos C minus cos D will become 2 sine C plus D by 2. So 2 sine A plus A, 2A. 3x by 2 plus x by 2 will become 2x. So 2 sine A plus x into sine of D minus C by 2. That will become x by 2 minus 3x by 2. That is minus x by 2 divided by x square. Tell me, anyone having any doubt? You can ask me. Am I doing it correctly? Don't know. Tell me. If there's anyone having any doubt, you can ask me now.
So can you scroll up a bit?
Yes.
So in the third step, the calculation part.
Over here.
Okay, so 2 cos c plus d by 2. That is okay. Cos sine c minus d by 2 a should be cancelled.
Oh, yes, you are correct. A plus x. C minus d by 2. No? A plus d, A plus 2x minus A minus x. So sine x by 2 it will be. Yes, you are correct. Absolutely correct. Same thing. Over here also we'll get x by 2. Yes, you are correct. Okay, I've done a mistake, everyone. So 2 sine x by 2 will be common. Not neither. Over here 2 sine A will not be there. Okay. So sine x by 2. 2 sine x by 2 will be common. Okay. Next. Okay. So I think now it is correct. Let's see. 2 sine x by 2 into sine of minus x by 2. So I think now I will get it into 2 sine x by 2. Okay. So see, in the denominator you have got x square. Okay, we have to divide it by 4 and multiply it by 4. So this will become limit x tends to 0. Okay. 4 into sine of minus x by 2 divided by x by 2 multiplied by sine of x by 2 multiplied by divided by x by 2. And over here, since we have divided by 4, so we need to multiply it by 4. Okay. Multiplied by sine of a plus x. Tell me, anyone having any doubt, you can ask me now. See, this 4 and 4 will get cancelled. This will go by -1. This will go by 1. So when you substitute 0, we are getting minus sign. Tell me, is it clear to everyone? If there's anyone having any doubt, you can ask me. Next, method 2. If you are unable to understand about, if you are unable to think about this method, I've got method 2 also. This was method 1, method 2.
So can you
Using
show
L'Hopital.
three part three ones, please?
Which one?
Question 3. I'll
Question
just
3.
say the question.
Okay.
Yes, sir. Okay.
Yes. Soham, check part 2. Okay, everyone, method 2, everyone. If you are unable to understand about the first method, pay attention. What you do is, see it is 0 by 0 form, use the L'Hopital. Okay, let us differentiate sine a plus 2x. Sine a plus 2x, this will become 2 cos a plus 2x minus 2 cos a plus x. Sine a is gone, divided by 2x. 2 will get cancelled. Again, let us differentiate. It will become minus 2 sine a plus 2x, then plus sine a plus x. The whole thing is gone. Okay. Now you substitute x equal to a. We'll get minus 2 sine a plus sine a. Done. This can be done easily by L'Hopital. Minus sine a will be your answer. Okay. Tell me, anyone having any doubt, you can ask me.
Sir, could you scroll up a bit?
Yes.
So aren't you using the u by v form for the differentiation?
No, why will I use u by v form? I have to differentiate the numerator separately and the denominator separately, not the whole thing.
Oh, okay, sir.
Okay, done, Rishabh?
Yes, sir.
Okay.
Sir, can you please show 3 part 2 once more? Question.
3 part 2. Solution or question?
No, sir, question.
Hmm. Okay, let us solve 3 part 2, everyone. 1 minus x into tan pi x by 2. What have we got? When you substitute x equal to 1, it is 0 into infinity form. Can you people understand? 1 minus x into tan pi x by 2. It is 0 into infinity form. So let us start. Okay, first of all, I'm going to do one substitution over here. Pay attention. Okay, 3 part 2. First of all, I'm going to do one
So can you
substitution.
show 3 part 3 once?
Yes. Okay, everyone, take a screenshot if you want. Yes. Anvesha, part 2 is correct. Part 3 is correct. Soham, part 3 is correct. Part 3 is okay. Shamli, part 3 is correct.
Sir, done.
Done. Okay. Yes, Adija, number 4 is correct. Rashishwari, part 3 is correct. Ritam, number 2 is correct. Okay, let us start with number 2. 3 part 2. Pay attention, everyone. Okay, so let x equal to, or let y is equal to 1 minus x. So as x tends to 1, y tends to 0. The whole limit will convert to limit y tends to 0, y into tan of. So everyone, x will become 1 minus y, right? So it will be tan pi by 2 into 1 minus y. Next, this will become limit y tends to 0, limit y tends to 0, y into. Now this will become tan pi by 2 minus pi by 2y. That is cot y. So I've got limit y tends to 0, y cot y. Okay, so this will become limit y tends to 0, y upon cot y, y upon tan pi by, sorry, cot y, it will be pi by 2y. So y upon tan pi by 2y. Okay, let us convert it into standard form. We have to multiply by pi by 2 in the numerator and divide by pi by 2. So multiplied by pi by 2, this will be the standard form into 2 by pi. So see everyone, this part will become 1. Okay, and finally you are going to get 2 by pi. If there is anyone having any doubt, you can ask me. Next, quickly solve part 3. Yes, Madhurya, part 2 is correct. Part 3 is very easy, everyone. You just have to convert it into standard forms.
Sir, could you check part 3?
Yes, Rishabh, part 3 is correct. Okay, let us start, everyone. Part 3. Limit x tends to 0. 1 minus cos of x divided by sine to the power 4x. Let us start. Yes, Rasheshwari, number 4 is correct. So everyone, let us keep on converting it into standard forms. This is part 3. So what you have to do is, we can write it as limit x tends to 0, 1 minus cos theta. 1 minus cos x is theta divided by theta square. So 1 minus cos x whole square multiplied by 1 minus cos x whole square. Okay, so see everyone, in order to convert it into standard form, we have to divide it by x to the power 4 multiplied by x to the power 4 divided by sine to the power 4x. Done. So see everyone, this whole thing will become half. The next one will become half whole square multiplied by 1. This will become 1 by 8. Done. Tell me, are you people getting yes or no? Tell me, Shwankit, is it clear? Abhipsha, Abhigyan, are you people getting?
Yes.
Okay. Ritam, is it clear? Ritam, Samragni, Shrijita, are you people getting?
Yes, sir.
Yes.
Okay. Quickly solve number 4. No, number 4 is good. Number 4. Quickly solve. Yes. Shamili, right answer. Okay, so let us start, everyone. We have got limit x tends to 0, x square into
So could you give a hint then?
hint.
Yeah.
Okay, see, it is written as cos theta into cosec theta. Okay, so simplify this a little bit. Think about what is cos pi sec square x. You'll get the result. Okay, so everyone pay attention. Over here, what do we get? Limit x tends to 0, x square into cos of pi sec square x. Okay, when you substitute x equal to 0, you have to understand where is the indeterminate form. When you substitute x equal to 0, you need to understand where is the indeterminate form. So when you substitute x equal to 0, you have got sec 0 as 1 and cos pi. So over here, we don't have any indeterminate form. Over here, we have indeterminate form. So let us convert this. This will become limit x tends to 0, x square into cos of pi sec square x divided by cosec of pi sec square x. Sorry. Sine of pi sec square x. Okay. Next, everyone pay attention. This will give us limit x tends to 0, x square into cos of pi sec square x. Now I need to convert the denominator into standard form. Acha, is it tending to 0? Just check. When you substitute 0 over here, you have got sine pi into 1. Okay. It is tending to 0. Okay. We have to convert it into standard limit. Okay. So we have got sine pi sec square x. Okay. Over here, the argument, but the argument is not tending to 0. Okay. We have to convert. Acha, can I write it as sine of pi into 1 plus tan square x? Tell me. Why did I write it as sine of pi into 1 plus tan square x? Because over here the argument was not tending to 0. So we cannot apply the standard limit. Okay. So this will become limit x tends to 0. Tell me, are you people getting? Did you understand the previous step? You have got x square into cos of pi sec square x divided by sine pi plus pi tan square x. So sine pi plus tan pi tan square x will become minus sine of pi tan square x. Now let us see whether the argument is tending to 0 or not. When you substitute 0, the argument is tending to 0. Okay, now let us convert everything into standard form. So this will become x square into cos of pi sec square x multiplied by pi tan square x. Okay, divided by minus sine pi tan square x. Okay, since you have multiplied by pi tan square x, you need to divide by pi tan square x. Okay, you see everyone, this whole limit will turn into minus 1 and pi tan square x divided by x square, that will become pi only in the denominator. So when x is tending to 0, this will become This will become cos of pi into sec square x. So cos pi is -1 divided by -1 into 1 over pi. This will become 1 by pi, which is equal to 1 by n pi. Therefore, n is equal to 1. Tell me, Soham, is it clear?
Yes, sir.
If there's anyone having any doubt, you can ask me now. Next, everyone, let us start.
Sir, can you explain the last step, please?
Yes. Last step I've converted into standard form. This is pi times square x. So I've multiplied by pi times square x. Right. But since I have multiplied by pi times square x in the numerator, I have to divide by pi times square x. Right. Tell me.
Yes, sir.
Okay. Now see, this is the standard form. This will become -1. Right. Minus into 1, -1.
Yes.
Right. And pi tan square x. This tan square x and x square, this will become 1. Right. Tell me.
Yes, sir. Yes, sir.
And then you substitute x equal to 0. X equal to 0, it will become cos pi. Cos pi is -1. So -1 by -1 into 1 over pi. Tell me, is it clear, Aibsha?
Yes, sir.
Okay. Next. Question number 5. Part 1. Limit x tends to pi by 2. Limit x tends to pi by 2. Tan x upon tan 5x. Start. Part 2. Part 2. Limit x tends to minus infinity x to the power 4 into sine 1 by x. Tell me, Joytra, are you getting up to this much?
Yes,
Plus
sir.
x square upon 1 plus mod x cube plus x square. Okay, part 3. Limit x tends to 0, cos of pi by 2 cos x upon sine of x square. Solve. Question number 6. Find the value of root over 1 by 2 into root over 1 by 2 plus 1 by 2 into root over 1 by 2 into root over 1 by 2 plus 1 by 2 into root over 1 by 2 plus 1 by 2 into root over 1 by 2 dot up to infinity. Keep solving, everyone. Okay, Soham, check your answer again. Rishabh, your answer is correct. Adrisha, your answer is correct. Rashishwari, check part 1. Abhisha, part 1 is correct. Shirika, part 1 is correct. Everyone pay attention. Part 1. 10x upon tan 5x. Is the argument tending to 0? Tell me, everyone. When you substitute pi by 2, is the argument tending to 0? Yes or no? No. So I have to do some substitution. Okay. Let y is equal to pi by 2 minus x. Let y is equal to pi by 2 minus x. Okay. So what are you getting? You'll get limit y tends to 0. Okay. Over here you are going to get tan of pi by 2 minus x upon tan of 5 into pi by 2 minus x. 5 pi by 5 into pi by 2 minus x. Okay. So this will become limit y tends to 0. Okay. Sorry. Tan of pi by 2 minus y. 5 into pi by 2 minus y. So what are we getting, everyone? Limit y tends to 0. Cot y upon cot of 5y. Okay. This will become limit y tends to 0. Tan 5y upon tan y. Now we have to convert it into standard form. Okay. So this will become tan 5y. We need to divide it by 5y. Then we have to multiply by 5y. Next, in the denominator, we have tan y. So just write tan y in the denominator. So see, everyone, this tan y upon y is converting into standard form. And this is also a standard form. So you'll get 1 into 5 into 1, which is 5. Tell me, anyone having any doubt, you can ask me now. Okay. Tell me, Rashishwari, is it clear?
Yes, sir.
Joyatra, have you
Sir, I got
understood?
5 only. I mean, I got my answer 5.
Yes, sir.
You gave 5.
Oh, I wrote by mistake 1. I got the
Ach,
answer 5
okay.
actually.
Okay. Anvesha, have you understood? Ronak,
Yes.
Ritam, Madhurya, is it clear?
Yes, sir.
Shimika, Shwankit, are you getting Shwankit?
Yes, sir.
Ahir, can you understand?
Yes, sir.
Okay. Solve part 2 and part 3 quickly, everyone. Okay, Soham, check part 3. Adija, part 2 is correct. Ahir, part 2 is correct. Okay, I'm starting with part 2, everyone. Limit extends to minus infinity. So everyone, over here, definitely we need to divide by x to the power 4. Let's start. Ahir, part 3 is correct. Soham, part 2 is correct. Shubhangi, part 2 is correct. Ritam, part 2 is correct. Adrija, part 2 is correct. So let's start, everyone. We have to divide by x to the power 4. Okay, what do we get? Yeah, but when we divide by x to the power 4, the whole denominator will tend to 0. Divide by x cube instead. We'll get limit x tends to minus infinity x into sine 1 by x. So x sine 1 by x will become 1 only, plus 1 by x cube divided by 1 over x cube plus mod of x cube by x plus 1 by x square plus 1 by x. So see, this will become 1 plus 0 upon 0 minus 1 plus 0 plus 0. This will become minus 1. Done. This was the easiest problem I've given today. Next, solve part 3, everyone. Yes, Soham part 3 is correct. Adrija part 3 is correct. Okay, I'm solving part 3, everyone. Limit x tends to 0, cos pi by 2 x cos x upon sine of x square. Let us start. In the denominator sine of x square, I can easily convert. Over there is no problem. Okay, over there is no problem. But over here I've got cos of pi by 2 cos x. Okay, everyone? When you substitute 0, you are getting pi by 2 cos pi by 2. That is 1 upon 0. So what you do is, you can write it as limit x tends to 0. Limit x tends to 0, cos of. So cos pi by 2 cos x, can I write it as sine of pi by 2 minus pi by 2 cos x? Okay, cos theta is equal to sine of pi by 2 minus theta. Okay, so see, this will become limit x tends to 0. Take pi by 2 common inside, you are going to get 1 minus 1 by cos x. Okay, so see, again we are getting 1 minus cos x form, everyone. Again we'll be getting 1 minus cos x form. So let us start. This will become limit x tends to 0, sine of pi by 2 into 1 minus cos x upon cos x. Okay, let us start converting it into standard forms divided by sine of x square. Okay, so everyone, we need to divide by 1 minus 1 by cos x. Okay, let us start converting. This will become pi by 2. We have to divide by pi by 2. Sine of pi by 2 into 1 minus cos x upon cos x. We need to divide it by pi by 2 into 1 minus cos x upon cos x. Okay, now since we have divided by this, we have to multiply by this. Same thing. Okay, next. And over here, sine of x square. So sine of x square, we need to multiply by sine of x square in the numerator. Multiply by sine of x square in the numerator. We have to divide by sine of x square in the numerator. Again, for sine of x square, we need to multiply by x square in the numerator. Divide by x square in the denominator. Okay. See, everyone, this whole thing will become 1. This whole thing will become 1. Okay. This whole thing will become 1. Next. Over here, 1 minus cos x. Pay attention. I'm marking it. 1 minus cos x upon x square. This will become half. Okay, let us start substituting. When x is equal to 0, this will become pi by 2 into. Achha, wait a minute. This was cos x minus 1, not 1 minus cos x. When we take cos x as LCM, this was cos x minus 1. So it will become minus half. So it will become pi by 2 into minus half into when you substitute 0, it will become 1. This will become minus pi by 4. Tell me. Is there anyone having any doubt? You can ask me now. I'll explain. Tell me, Aisha, is it clear? Shashwato,
Yes,
have you
sir.
understood?
Yes, sir.
Joyatra, are you getting?
Yes, sir.
Okay. Shwankit, is it clear?
Yes, sir.
Okay. Tell me, Shamli, Shinika, is it clear? Samragni, is it clear? Ritam,
Yes, sir.
have you understood? Okay. Solve number
Yes.
6, everyone. Okay, I'm solving number 6. Pay attention, everyone. Okay. This seems like we can convert it into some trigonometric series, if you can understand. Seems like we can convert this whole thing into some trigonometric series. 1 by root 2.
So we have to do something with cos. Right?
Yes, 1 by root 2. Can you people understand? 1 by root 2 is equal to cos pi by 4, right, everyone? Tell me. Yes or no?
Yes, sir.
1 by root 2 is cos pi by 4. So everyone, I'll find out a pattern and then I'm going to solve, okay? So if this is cos theta, let's see what is the second term. Second term is equal to root over 1 by 2 plus 1 by 2 into cos theta. Okay, let's see what are we getting. Root over 2 as LCM. Numerator is 1 plus cos theta. What is 1 plus cos theta? 1 plus cos theta is equal to 2 cos square theta. So it will become root over cos square theta by 2. Oh, what is root over cos square theta by 2? This is cos theta by 2, right,
Yes.
everyone? Okay, are you people able to visualize? Tell me, number
Yes.
6. If the first term is cos theta, second term is cos theta by 2, third term is cos theta by 2 square, third term is equal to cos theta by. Okay, like this it goes on. Okay, so we have got limit n tends to infinity cos theta into cos theta by 2 into cos theta by 2 square into dot 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 cos theta by 2 to the power n. Right, tell me everyone. Acha, we have to solve this cosine series. Acha, do you remember how to solve this kind of cosine series? We have done it in trigonometry, right? We have to multiply and divide by sine of the smallest angle. Over here, the sine of the smallest angle is sine of theta by 2 to the power n. So this will become limit n tends to infinity sine theta by 2 to the power n. But when we are multiplying by sine theta by 2 to the power n, we have to divide by sine theta by 2 to the power n. Right, this will become cos theta into cos theta by 2 square into dot 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 cos theta by 2 to the power n. Tell me, if there's anyone having any doubt, you can ask me now. So everyone, this will become limit n tends to infinity. Okay. Acha, sine theta by 2 to the power n into cos theta by 2 to the power n. This will become sine 2 theta by 2, right? So it will become sine theta by 2 to the power n minus 1. The whole thing will be divided by 2. So divided by 2 sine theta by 2 to the power n. Okay. Multiplied by cos theta. Multiplied by cos theta by 2 square. Dot 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 up to cos theta by 2 to the power n minus 1. So after n steps, what will you get? Are you people able to understand? After n steps, you will get sine theta in the numerator. After n steps, I mean, After n steps, you'll get limit n tends to infinity. You'll get sine theta in the numerator. In the denominator, you are going to get 2 to the power n sine theta by 2 to the power n. Okay. And what? Okay, only this much only. Okay. So everyone, as n tends to infinity, argument tends to 0. Right. Shujita, are you getting?
Yes, sir.
Shujit- Shashwato, are you getting this? Tell me. Samragni, Shashwato,
Yes, sir.
Ronak, Rishabh,
Yes, sir.
Yes.
Rasheshwari,
Yes, sir.
Adrija, Avifsha, are you people getting?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So this tend to 0. So that means in order to convert it into standard form, we need to multiply by theta by 2 to the power n. If you have multiplied by theta by 2 to the power n, you have to divide by theta by 2 to the power n. Now see, 2 to the power n, 2 to the power n gets cancelled, everyone. What are you getting? You're just getting sine theta by theta. Now, everyone, what was theta? You tell me, everyone. If cos theta is equal to pi by 4, sorry, cos theta is equal to 1 by root 2, what is theta? Tell me. If cos theta is equal to pi by 4, sorry, cos theta is equal to 1 by root 2, so theta is equal to pi by 4, right? If cos theta is equal to 1 by root 2, this implies theta is equal to pi by 4. So what are you getting? You'll get sine pi by 4 divided by pi by 4. Sine pi by 4 divided by pi by 4. This will become how much? 1 by root 2. So it will be 4 pi root 2 pi. Wait, let me check the answer. Over here, the answer is given something else. Am I making a mistake? Let me see. I've taken cos theta as pi by 4. So the next one will become cos theta by 2. Cos theta by 2 square up to cos theta by 2 to the power n. Acha, everyone, over here there are how many terms? Just check. Over here there are n plus 1 terms, right? Pay attention. Over here there are n plus 1 terms. Just let me think. Over here there are n plus 1 terms. If you just multiply by cos theta by 2 to the power n, oh, this will become sine 2 theta, everyone. Everyone pay attention. Ultimately, you'll get sine theta cos theta, right? So after n steps, this will become sine 2 theta. Sorry, everyone. This will be sine 2 theta. Are you people able to understand where I made the mistake? With cos theta also, sine theta will be multiplied, then it will become sine 2 theta. Right, tell me, everyone. Hello, are you people getting?
Yes, sir.
It will become sine 2 theta, and it will be, and how many steps we are doing? With cos theta, we are doing once, right? Sorry, not cos theta. With sine theta, we are doing once. So we are doing 2 to the power n plus 1 times. So denominator, it will be 2 to the power n plus 1. Sorry. This will be 2 to the power n plus 1. Okay. And this will be sine 2 theta. Sine 2 theta divided by 2 to the power n plus 1. Okay. So these two will get cancelled. Only 2 will be left in the denominator. I think now we should get the answer. Let's see. So we have got sine 2 theta divided by 2 into theta. This is what we are going to get. Let's see. So if cos theta is equal to 1 by root 2, theta is equal to pi by 4. Theta is equal to pi by 4, 2 theta is equal to pi by 2. So we have got sine pi by 2 divided by pi by 2. So sine pi by 2 is 1. Yes, this will be 2 by pi. Let me see. 2 by pi is given. Yes, 2 by pi is the correct answer. Tell me. Anyone having any doubt, you can ask me now. If you're having any doubt, you can ask me now. Tell me. Next. Okay, after this, we have some questions on expansion of functions. Okay, do you people remember Taylor and Maclaurin series expansions?
So,
Okay, expansion of functions. Okay, there are some expansions you need to remember. If you remember it, it will be very helpful. Okay, in some of the problems. Okay, like I remember one question came in JEE Advance 2020 on limits, where you cannot solve without expansion.
yes, sir.
Okay, x minus x cube by 3 factorial plus x to power 5 by factorial dot up to infinity. But even if you forget, I have taught you how to expand it, right? Do you remember, everyone? By using Taylor series expansion, Maclaurin series,
Yes.
use Maclaurin series, it will be helpful. Then cos x is equal to, so see,
Sir, Taylor
sine
series is for f of a and Maclaurin is for f of 0.
f of 0. Okay, better to use Maclaurin series. Sin x, over here you see only odd powers. For cos x, you have even power. 1 minus x square by 2 factorial plus x power 4 by 4 factorial dot up to infinity for all x belongs to real. Next, tan x. For tan x, just remember the first three terms. Nothing much. X plus x cube by 3 plus 2 by 15 x to the power 5. Only this much. You don't have to remember much. Only remember the first two, three terms. Number T. ln 1 plus x. ln 1 plus x will be equal to x minus x square by 2 plus x cube by 3 minus dot up to infinity. So ln 1 minus x, ln 1 minus x will be equal to x minus x square by 2 plus x cube by 3 dot up to infinity for mod of x less than 1. Okay, next, f 1 plus x. Wait a minute. A, b, cosine x, cos x, tan x, ln 1 plus x, uh, ln 1 minus x. Wait, ln 1 minus x, I think I'm making a mistake. It will be minus x square by 2 minus x cube by 3. Okay, this is valid for mod x less than 1. This is also valid for mod x less than 1. Next, number f 1 plus x whole to the power 1 by x. This will be equal to e into 1 minus x by 2 plus 11 by 24 into x square minus dot. Okay, next, number g e to the power x, everyone knows 1 plus x square by 2 factorial plus x cube by 3 factorial plus dot. Next, number h e to the power x 1 plus x ln a plus x ln a whole square by 2 factorial plus dot up to infinity. Okay, proof proof can be done using Maclaurin series. Okay, if you want me to show any proof, let me know. Any of the expansion, I'll expand it. Maclaurin series. Okay. F of x will be equal to f of 0, f of 0 plus f dash 0 by 1 factorial into x plus f double dash 0 by 2 factorial into x square plus dot plus up to infinity. Okay. Next, some exponential functions are there. Okay, remember, there are some standard forms. Limit exponential functions. Exponential functions. Okay. Limit x tends to 0. A to the power x minus 1 upon x. This will be equal to ln a for some a greater than 0. Okay, proof can be done easily by L'Hopital, or you can use exponential expansions. I mean, you can expand it over here, a to the power x, you can expand and you can get it. Just expand up to 2, 3 terms, you'll get it. Or you can use L'Hopital. Limit x tends to 0, e to the power x minus 1 upon x. This will be equal to 1. Next. So similarly, everyone, if x is tending to infinity, x will change to 1 by x. Limit x tends to infinity, x into e to the power 1 by x minus 1. This will be equal to 1. Next. Number 4, if you need the proof of any of the expansion, any of the standard forms, let me know. Limit x tends to 0, ln 1 plus x upon x. This will be equal to 1. How to solve? I mean, how to prove it? Just use L'Hopital, you will get the result. Okay. For example, how to use it? See, everyone, limit x tends to 0, e to the power 4x minus 1 upon tan x. Okay. This can be done easily by converting all of them into standard forms. E to the power 4x minus 1 upon 4x multiplied by 4x by tan x. Done. You see, this will become 1 into 4, which is 4. Okay. Let us do some problems. Question number.
Sir,
Yes, tell me.
so in the expansion of ln 1 minus x, you wrote that the mod of x would be less than 1. But
Hmm.
sir, if x can be equal to minus 1,
X can be equal to minus 1. No, I have written strictly less than 1.
yes, but I'm asking if x equal to minus 1, then this will not
And
be
then
given.
0 plus,
Yeah,
it is there in the domain.
yeah.
What is the problem? It
I
is
was
there in
asking
the
that
domain.
wouldn't that be x greater than equal to minus 1 and less than 1?
X greater than or equal to minus 1. See, the point is, if this is the fraction, okay, then only the series converge.
Okay.
Okay,
No,
otherwise it will.
no, in the lower one, ln 1 minus x.
What? It should be greater than 1.
No, it should be less than 1, that's fine. But x here can be equal to minus 1.
X can be minus 1,
No?
but mod of x is less than 1. You see, I have taken mod of x means x is greater than minus 1 but less than 1. Mod of x less than 1. See,
I was asking if the condition is sure. Then this is defined
are
for
you
this
getting?
condition only.
Yes, only for this condition, not
Okay.
for minus 1.
Okay.
Okay. Everyone try this out. Question number 7, 7 part 1. Limit x tends to 0. E to the power 10x minus e to the power x upon tan x minus x. Solve. Part 2. Limit x tends to 0. E to the power x square minus cos x upon x square. Solve. Part 3. Limit h tends to 0. a to the power x plus h plus a to the power x minus h minus 2a to the power x upon h square. Part 4. Okay, solve, everyone solve. Okay, solve these three parts. Then there's another form.
Sir, could you show me the properties for 1 second?
Yes.
Oh, sir, got it.
Okay, should I start, everyone?
So could you check?
Yes, Soham, your answer is correct. Adrija, your answer is correct. Okay, let us start, everyone. Okay, Shwankit
Sir,
has
could you
also
check one
sent. Yes, Shwankit, right answer. Let's see. Yes. Shamili, part 1 is correct. Rishabh, part 1 is correct. Everyone, let us start. Achha, Soham, which answer is this? Part 2. Part 2 is also correct. Okay, let's start, everyone. Part 1. Okay. So, everyone, you just take e to the power x common. Let's see what are we getting. Limit x tends to 0. E to the power 10x minus x minus 1 upon 10x minus x. See, this is the standard form, everyone. Okay. Because, see, the argument is tending to 0. When you substitute x equal to 0, the argument is tending to 0. So, this is the standard form. So, this will be equal to 1. Done. Identify the standard form. It is very important. Samragni check part 2. Abhipsha part 1 is correct. Okay. Quickly solve part 2.
So e to the power 10x minus e to the power x, how could you write e to the power 10x minus x?
I have taken e to the power x common. Now is it fine?
Yes, sir.
Okay. By mistake, I didn't write this. Okay, part 2, everyone. Let us start. E to the power x square minus cos x upon. So what you do is you subtract and add 1. Done. Once you subtract and add 1, the problem is done only. It will become 1 minus cos x upon x square. Rishabh, check part 2. Shwankit, part 2 is correct. So
Sir,
part 2, yes. Abhipsha, check part 2. Rishabh, part 2 is correct. Adrija, part 2 is correct. Limit extends to 0. E to the power x square minus 1 Okay, I have subtracted one, so I have to add one. So plus 1 minus cos x upon x square. Tell me. Shashwato, are you getting? Yes or no? So see, this is
Yes, sir.
limit x tends to 0. E to the power x square minus 1 upon x square. This is the first limit. Plus limit x tends to 0. 1 minus cos x upon x square. Done. The first one is 1. Second one is half. 1 plus half is 3 by 2. Okay. Quickly solve part 3. Okay, let us start everyone. E to the power x plus h.
So just wait a minute, just 1 minute.
Okay, solve. Just keep on converting it into standard forms. Okay. Soham, check your answer again. Okay, everyone pay attention. So see, e to the power x plus h plus e to the power x minus h minus 2 e to the power x upon h square. Pay attention. This is part 2, part 3. So this will give us limit h tends to 0. Okay. Over here, you take e to the power x common. What are we getting? E to the power h plus 1 by e to the power h minus 2 divided by h square. So see everyone, this will become limit h tends to 0, e to the power x multiplied by. See, it is a perfect square, everyone. It is actually e to the power h by 2 minus 1 by e to the power h by 2 whole square. Okay, everyone? This is e to the power h by 2 minus 1 by e to the power h by 2 whole square. Okay. So everyone, over here, this will become limit divided by h square. Forgot to write h square. Okay. Now see, this will become limit h tends to 0. Okay. You can take e to the power h by 2 as LCM. This will become e to the power x into e to the power h by 2 as LCM. Okay. Numerator would be e to the power h minus 1 whole square. This whole thing is divided by h square. Let us start converting it into standard form. I hope you people can see e to the power h minus 1 upon h square. This is the standard form. Taking e to the power h by 2 as outside, e to the power h by 2 outside, this will become limit h tends to 0, e to the power x upon e to the power h multiplied by e to the power h minus 1 upon h whole square. So e to the power h minus 1 upon h, this will become ln a whole square. Okay, everyone? So let us substitute h is equal to 0. This will become e to the power x multiplied by ln a whole square. Tell me, anyone having any doubt, you can ask me now. Tell me. Ahir, is it clear? Ahir, Oibsha, Abhigyan, Adrija,
Yes, sir.
Soham, Joytra,
Yes,
Anvesha,
yes, sir.
Rasheshwari.
Yes, sir.
Ritam,
Yes, sir.
Ronak, Samragni, are people getting?
Yes.
Yes, sir.
Okay. Next. Everyone pay attention. Next one is very, very important. Very, very, very important, everyone. If you see PYQs, you'll get a lot of questions coming from this part. That is 1 to the power infinity form. Okay, everyone? 1 to the power infinity form. Okay, I'll give you a direct formula of, of solving 1 to the power infinity indeterminate form. Very important, everyone. Okay? See, first of all, there are two standard forms we need to understand. That is limit 1 x tends to 0, 1 plus x whole to the power 1 by x. This will be equal to e. And this is also equal to limit x tends to infinity, 1 plus 1 by x whole to the power x. Okay, both are very important. See, over here the base is tending to 1, whereas the power is tending to infinity. Okay, let us see the proof. I'll give you a standard result also, how to resolve. Okay, so let L is equal to limit f to the power g. Okay, everyone, let L is equal to limit f to the power g. Okay, where where f is taken as 1 plus x and g is taken as 1 by x. Okay, everyone. It's a very standard, it's a very standard result, everyone. Pay attention. I'll take log on both sides. Ln L will be equal to limit h tends to 0. Ln of f to the power g. G will come outside. This will become limit h tends to 0. G into ln f. Okay. Next, everyone, let us substitute. This will become limit h tends to 0. Okay. Acha, before substituting, okay, let us find out the standard form. So everyone, can I write it as, wait a minute, can I write it as g into ln 1 plus f minus 1 upon f, so see, limit 1 plus ln of 1 plus f minus 1. Can I write like this? Tell me, everyone. Pay attention. Instead of f, can I write it as 1 plus f minus 1? Tell me, everyone. Yes or no?
Yes.
Hello. Are people getting? So everyone, ln of 1 plus f minus 1, I have to convert it into standard form. Okay, this will become limit h tends to 0. Sorry. Why h tends to 0? X tends to 0. Because the variable is x, not h. X tends to 0. Okay, g into ln of 1 plus f minus 1 upon f minus 1. And next we need to multiply by f minus 1. Okay, now everyone, this part will become 1. Okay, now you substitute g and f. Okay, everyone, this will become limit x tends to 0. What is f? What is f? F is 1 plus x. Sorry. And g is 1 by x. So 1 by x into 1 plus x minus 1. 1 will get cancelled. X will get cancelled. We'll get 1. So ln L is equal to 1. So what is the value of the limit? Limit will be equal to e to the power 1. E. Tell me, is it clear to everyone? Yes or no? How are we getting e over here? Tell me. If there's anyone having any doubt, you can ask me now. Tell me. Anyone having any doubt?
Sir, can you scroll up?
Yes.
Yes, sir. Done.
Okay, next. Okay, there are some standard results I'm going to write. Acha, next. Limit h tends to 0 and tends to infinity. Cos h whole to the power n. This will be equal to 0 only. And limit, this is also 1 to the power infinity form. See, when you substitute h equal to 0, you are getting cos 0, that is 1. 1 to the power infinity form. Next, limit h tends to 0 and tends to infinity. Okay, over here, sec h whole to the power n. Sec h whole to the power n. Can anyone tell me what is the value over here? Limit h tends to 0, sec h and tends to infinity. What is sec h whole to the power n? Can anyone tell me? Raise your hand. Limit h tends to 0 and tends to infinity. Raise your hand. Tell me. What happened, everyone? Acha, can anyone tell me how I got 0 over here? This is the 1 to the power infinity form. How I got 0 in the first place? Tell me. At least tell me. Okay, so you people are just copying, not understanding. Tell me, raise your hand. How I got 0 in the first place? Just see. H is tending to 0, right, everyone? Pay attention. H is tending to 0. H is not exactly equal to 0. So cos H will be something less than 1. Yes or no, everyone? So something less than 1 whole to the power infinity will tend to 0. Right, tell me, everyone. Now tell me, what is limit h tends to 0 and tends to infinity sec h whole to the power n? Tell me, anyone. If you understood the first one, you should be able to answer the second one. Raise your hand.
So
Hmm. Okay, Rishabh, tell me.
So will it be infinity?
Infinity. Right, everyone. Because sec h is something greater than 1, everyone. Whole to the power infinity, this will be infinity. Next, everyone. I'll generalize it, everyone. If limit x tends to a, f to the power g is given. If limit x tends to a, f to the power g is given, where f is tending to 1 and g is tending to infinity. Okay, then we can write it as, then we can write it as, okay, number 1, limit x tends to a, e to the power g into ln f, or we can also write it as number 2, or we can also write it as e to the power limit x tends to a, g into ln f. Okay, then I'm going to convert it into standard forms. So everyone, same way, can I write it as e to the power limit x tends to a, g into ln of 1 plus f minus 1. Okay, now see, let us convert it into standard form divided by f minus 1 multiplied by f minus 1. So see, finally you are going to get e to the power limit x tends to a. If you remember this result, you will be able to solve it within seconds. You will be able to solve the problems within seconds. Okay, you can directly find out the limit using this expression. Okay, for example, you see, everyone. For example, limit x tends to 0, 1 plus 2x whole to the power 5 by x. Okay, you can directly write down the limit as limit x tends to 0, e to the power limit x tends to 0, 5 by x into 1 plus 2x minus 1. 1 will get cancelled, x will get cancelled. Answer is e to the power 10. Tell me, are you people getting yes or no? How you can solve the questions quickly using this result? Tell me, anyone having any doubt? Hello, till now, anyone having any doubt?
No, sir.
Okay. Okay, let us do some problems. Okay, let's do one or two problems, everyone, for today. Okay, quickly. Based on this result, let us do one or two problems. Okay. Question number what? Question number 8, part 1. Limit x tends to 0. ln 1 plus x upon 3 to the power x minus 1. Part 2. Limit x tends to e ln x minus 1 upon x minus e. Part 3. Okay, this is the last one, everyone. Limit x tends to 1. 1 plus x upon 2 plus x whole to the power 1 minus root over x upon 1 minus x. Okay, these are the last set of problems. Quickly solve. Okay, Soham, check your answer again. Ahir, part 1 is correct. Rishabh, part 1 is correct. Adija, part 1 is correct. Samragni, part 1 is correct. Shinika, part 1 is correct. Okay, so everyone, let us start with part 1. We have got limit x tends to 0. Okay, Jatra, check your answer again. Okay, Shubhangi, part 1 is correct. Let us start, everyone, part 1. Shashwata, are you solving?
Yes, sir.
Ronak, check part 1. Ahil, part 2 is correct. So everyone, this will become limit x tends to 0. ln 1 plus x. We need to divide it by x to make it into standard form. multiplied by x by 3 to the power x minus 1. This will be 1 divided by ln 3. Done.
So could you
Part 2.
scroll up a bit?
Yes. Ronak part 2 is correct. Atija part 2 is correct. Rishabh part 2 is correct. Soham part 2 is correct. Part 2, everyone directly differentiate. It's very easy. Okay. Part 2, you can directly differentiate. Ln x minus e. So see, we can do it by standard form also, but over here differentiation seems easy. You can directly write it as ln 1 by ln x divided by 1. So now you substitute e. This will become, sorry, 1 by x divided by 1. 1 you substitute e. This will become 1 by e. Done. Last one, everyone. Part 3. Quickly solve. Yes, here part 3 is correct. Yes, Rasheshwari part 3 is correct. Anvesha part 3 is correct. Adija part 3 is correct. Shubhangi part 3 is correct. Rishabh part 3 is correct. Soham part 3 is correct. Everyone, let us start. Done. So it is 1 to the power infinity form. Again, what you need to apply, everyone? Same thing. You directly apply the standard form. Part 3. Shijita, are you solving?
Yes, sir. I have a question here. How is it 1 to the power infinity form?
Because when you substitute, oh no, it is not 1 to the power infinity form.
So it can
Wait.
be directly solved. 1 minus root x plus
Yes,
1
yes.
minus x 1 by 1 plus root
Yes,
x.
sir.
Oh, yes. 1 plus 1, 2 by 3. 2 by 3 root over.
Root over 2 by
Directly we
3.
can solve this.
Oh, wait. I was thinking that I have given 1 to the power infinity form problem. 2 plus x whole to the power 1 minus root over x upon 1 minus root over x into 1 plus root over x. These two will get cancelled. So when you substitute 1, this will become root over 2 by 3. I was thinking that I have given 1 to the power infinity form problem. Okay. Okay, so let us do one problem from 1 to the power infinity form. Part 4. Last one, everyone. Last one. Let me see. This time 1 to the power infinity. Okay, this one will work fine. Limit x tends to. Okay, let us do an easy one. Limit x tends to infinity. X upon x plus 1 whole to the power x. Solve. Last one, everyone. X upon x plus 1 whole to the power x. Ronak, this is the answer of part 4 or part 2?
Sir, part 3.
Part 3. No, part 3 is not correct. Part 3, this is not 1 to the power infinity form.
Sir, I have deleted that message.
Oh, let me see.
I haven't sent any answer.
Okay, okay. Is Soham right answer? Ahir right answer? Okay. So everyone pay attention. Oipsha right
Sir,
answer. Shashwato right answer. Shubhangi right answer. Rishabh right answer. Adija right answer. Okay, let us start. So it is 1 to the power infinity form. Let us start. So part 4. It will become e to the power limit x tends to infinity. X into x by x plus 1 minus 1. G into f minus 1. This will become e to the power limit x tends to infinity. Okay, x into x plus 1 as LCM. Numerator would be x minus of x minus 1. So x gets cancelled. You'll get e to the power limit x tends to infinity minus x upon x plus 1. This limit will tend to minus 1. This will be e to the power minus 1, which is 1 by e. Done. Tell me, anyone having any doubt, you can ask me now. Tell me, Joytra, is it clear? Anvesha,
Yes, sir.
Rasheshwari, is it clear?
Yes, sir.
Rishabh,
Yes, sir.
Samragni,
Yes, sir.
Shamini, Shinika, are people getting?
Yes.
Okay. So I think everyone, we can keep it till now. Next class on Sunday, we'll again continue. Sunday, we have a test. After the test, we'll again continue. Thank you, everyone, and good night. Those who have a doubt, you can stay back. Others can leave or stay. You have a choice. Thank you and good night, everyone.
Okay, so good night.
Sir, can I ask my
Yes.
Good night,
doubts
sir.
on Friday only? Tomorrow I have school, so
Actually, I hear on Friday I might not be able to conduct the doubt class. There might be a problem. So
okay, sir. So I'm sending you my doubt.
send. How many are there?
Right now there are only one. There is only one doubt. Another question I solved, but
Acha,
by Friday I would have had like more than one doubt.
okay. Then what you do is you keep on sending it to me in WhatsApp. Okay.
Yes, sir.
If I get time, I'll solve it and send it to you. Okay.
Yes, sir. Thank you, sir.
Then you send the one which we have currently.
Yes, sir.